In this video, we'll look at the trigonometry of right-angled triangles and begin to look at trigonometric functions. So let's go back to the beginning, and we have a right-angled triangle here on the left. We've nominated the angle theta as here. Okay, so I won't cut up the page to get rid of that. And that means that the opposite the right angle here is the hypotenuse, and opposite the angle is the opposite side. Next to the angle is the adjacent side, and then the trigonometric ratios are sine theta is opposite over hypotenuse. Cosine of theta is the adjacent side length over the hypotenuse length, and the tangent of theta is the opposite side length over the adjacent side length. All right, so come back right from the start. Let's have a look at the exact trigonometric ratio. So here for a triangle with hypotenuse length 2 units, opposite the 60-degree angle, this side length here is square root of 3, and the base of the triangle here is 1 unit long. On this triangle here, we have the base length and the vertical lengths both equal to 1, and the hypotenuse equal to square root of 2. These two angles are 45 degrees, right angle in here. Okay, and this gives us certain ratios. So for instance, with the exact ratio here, the sine of 60 degrees will be the sine of 60 degrees will be the opposite side length, square root of 3, divided by the hypotenuse 2. All right, using each of these ratios applied to each of these triangles for some given angle. Let's have a look down here, and let's pick up an example. All right, so here's a triangle here, hypotenuse unknown length, the base length 7 units, the vertical height 5 units. All right, from the tangent ratio, given that we have for this angle we have the adjacent side and the opposite side, then the tangent of theta, or tan theta, is 5 over 7. We can find the angle theta in degrees. In this case, we'll do it in degrees, but we could equally do it in radians. I'm choosing degrees at the moment, but most of when working with trigonometric functions, we'll work in radians. So theta will be the inverse tangent of 5 over 7. Put that through a calculator or symbolic software program, 35.54 degrees. Okay, sine of we can now find, okay, so we have theta. Having found theta, we could then use the sine ratio, which is the sine of theta is opposite over hypotenuse. So sine 35.54 degrees is equal to 5 over the hypotenuse. Okay, rearrange that. A times sine 35.54 degrees is equal to 5, and then dividing through by the sine of 35.54 degrees will give us that A, the side length, is equal to 5 over sine 35.54 degrees, and it gives us approximately, to one decimal place anyway, 8.6 units long for the hypotenuse. Let's start to have a look at trigonometric functions now. That's functions involving sine, cos, and tan. I'll start for the moment with sine and cos, and the general form I'm talking about here is y equals, let me just move that down further a little bit more, there we go, about there, y equals plus or minus a sine or cosine of n times x plus h. And what we're saying, it's the sine of all of this. Okay, so perhaps extra set of brackets could have been put in there. So sine of n times x plus or minus h, or cosine of n times x plus or minus h, and then plus or minus a up front. On the end, plus or minus constant k. So a, n, h, and k are real numbers. All right. An expression of this form, a trigonometric function, this form has a period 2 pi on n. We'll see the graphs for these later, but has a period of 2 pi divided by this n factor here. So if you can factorize out the n, you'll be able to work out the period, simply 2 pi divided by n. The amplitude, of course, will be a, the term out front. Okay, plus or minus k moves the graph up or down. So if we were to plot this, we would find that plus k would lift the graph up, minus k would take the graph down. All right. Plus or minus h moves the graph left or right, minus h moves it to the right, plus h moves it to the left. A dilates the graph in the y direction by a factor of a units, so it stretches in the y direction. N dilates the graph in the x direction by a factor of 1 on n, so x being horizontal direction, okay, y is the vertical, okay, x is the domain, the argument, okay, y is the range, all right, codomain. So n dilates the graph in the x direction by a factor of 1 on n units, all right. Y equals minus f of x reflects the graph about the x-axis, about the horizontal axis, the domain axis, the domain variable. Y equals f of minus x reflects the graph about the y-axis, and y equals minus f of minus x reflects the graph about both axes. Okay, so brief introduction there, and we will see more of that in coming videos when we flesh that out.